we're going to talk about something very interesting. And first of all, I want to start off with going back into history. To the beautiful year of 1972, March 4 precisely, I was born. Yes, greatest day on earth. But more importantly, a month later, this company was founded in Osaka in Japan, Roland. And Roland creates all kinds of stuff like synthesizers, DJ gear, whatever you like for musicians. And in 1980, they had a great idea. Let's build something that can make beats for you. A drum computer.
Introducing the world's most advanced rhythm machine, the Roland TR-808, a revolutionary computer-controlled rhythm machine offering more percussive variations and effects than virtually any other machine on the market. Rhythm pattern visualization, built-in memory, realistic sounds, synchronous performance. Roland, we design the future.
They designed the future in 1980. Don't you love the 80s graphics there? It's like a Tron feeling to me. But they introduced the TR-808, the first drum computer that you could really make your own sequences. It's not like it's patterns that are predefined. So that was great. And you know, the product was good, but it failed miserably. I think they made about 8,000 copies of them, and they sold way too less. So in 1983, we learned from our experience with the 808. Let's introduce the 909. Don't laugh. It is a great product, but it was way ahead of its time because, again, they made about 10,000 copies and they sold a few hundred of them. You had to pay around, let me calculate, back in the day about 2,500 left for it, so 1,200 euros. But they all ended up in second-hand stores, on the dump sites and whatever. But about 5 years later, this guy bought one for about $50, so 100 left or more or less. And this is Tyree Cooper. He worked as a DJ and a producer in the warehouses in Chicago, where in the warehouses house music was created, and he combined it with hip-hop, so we got something called hip house. The genre I grew up with and I really like, but he used the 909 for many songs to produce. But not only in the house scene, also the queen of pop, Madonna, used it on her single Vogue, for instance, the 909. What about these guys? Daft Punk used it on 909 Revolution. They even call their song like that. And let me do a test. You can shout out if you recognize this one. Anyone? Eric E. and Jakit K from Technotronic, Pump Up the Jam, 909. And probably know this one as well. Ray and Anita from Amsterdam, 2 Unlimited. Well, they say it's a Belgian group, but we say it's Dutch. I'm from the Netherlands, so it's Dutch. As I say, I'm Rowdy. I used to be a club DJ in the late 80s and the early 90s. Loved playing especially hip house and house music. I built my first website in 1996. With only HTML, that's all I had. Nowadays, I'm a front-end focused senior DevOps engineer with special attention for accessibility and usability. Maybe next week I have another word to add, I don't know. And I'm also a Google developer expert in web technologies for PWA and for Project Fugu. So that's all the fun stuff you can do in the browser that does. Most of them are not really useful now in your job, but hopefully later on. All right, let's get started with the Web Audio API. You've probably seen the Web Audio API in your browser already because that's just the audio player there, the HTML5 audio player, for instance. But the Web Audio API makes it possible to play sound, but also to create and manipulate sounds. It's well supported in every major browser. I could finally drop IE last year, so that's good. To create music, we need something, or create sound, let's say, you need something that's called an audio context. That's more like the wrapper around things. To do that in JavaScript, you create a variable with new audio context. That's it. That audio context needs an oscillator node. That oscillator node really creates that sound. You instantiate that and you give the audio context to it, but it needs two extra things. It needs a frequency on which the sound will be created, and the frequency is measured in hertz. Like if it's a low frequency, low hertz, the sound will be very low. If it's high, it's get high. It's easy as that. So for instance, I can set it to 440. And 440 is, if you're a musician, that's the A note. But it also needs a waveform, and a waveform will determine how that note will sound. And there are 4 different ones. You can make your own as well, but 4 standard ones. We have the sine, for instance. You hear some clicking, but it's just going up a high note, but it's kind of like nice and flowing. The triangle is flowing as well, but maybe less nice. Then we get to the freaky part, square. Square sounds like a little bit like the 8-bit games we used to play. I'm going to blow these speakers, cool. And we have the sawtooth that gradually goes up and then drops. Sorry, Laura. I told you would stay awake. So for instance, I'm going to use the sine waveform here. So to play that sound, I need to connect that oscillator to the context destination. And the destination is simply said, your speakers. I will start it, and I will use the CTX current time, so the timer of the audio context itself, not something with set timeout or something, because this one is way more accurate. And I can say, well, I'll stop it after 2 seconds. If I don't stop it, it will go on forever. That's not what we want. So an A note will sound like this. But that's fun, but I don't know. I want to do this. I want to make a drum computer, a rhythm composer TR-909. So what I can do is create some basic sounds like a kick or a hi-hat or a snare with that web audio API. And it will sound like this. So you have your kick. Let's get a snare. It's okay-ish, but look at the amount of code I have to write for this. I have to make something that's called a distortion curve and a generate white noise buffer and a lot of shit, play triangles, I don't know, wave shapers. This is only the kick, by the way. Now we get to the share part. It's like, yeah, and I can't even forward this. We have to wait until it's finished, but this is not the way to do it, right? It's fun and games until it isn't anymore. So let's use something else. Let's use samples. And the best way to do that is to use wave files. It's been around since 1991. It's uncompressed. It's very crystal clear sounds. It's better than MP3 to use for this because you're only using small samples. So it's not like you're having a wave file of, I don't know, 20 megs or something. It's very small. And for instance, I can create a small drum computer like this. I have some paths defined in an HTML page. That would look like this. It's just 4 buttons that have a class to style it a little bit. They have a data attribute called node. I will get back to that later, why it's in there. And I have given them a data attribute called wave with the particular wave file I want to play. So the 909 kick, clap, etc. So what I now can do is just select them all. And for each pad, I'm going to attach a click event. And when I click on a pad, it will load that wave file that's in the data wave attribute. Of course, I need to load it first. I need to load it, and then I need to play it. So I need some extra code for that as well. So the load file will take the wave, and it will fetch it from your local system or from the website. It's just like you would call an API. You have to do magic stuff with it, make it an array buffer, create a decoded audio data with that array buffer, and then in the end, you have an audio buffer. You can then pass through to the play wave. That needs to create an audio buffer source node. Give that audio buffer to it. You connect to the destination, to your speakers, and then you can start it. Still a lot, right? Too much. But it's possible, but a better way is using this. This is Tone.js. That's a library, an open source library that makes it way easier for you to interact with the web audio API. You can manipulate stuff with it, but also it's way easier, for instance, to load WAV files. Because loading a WAV file in Tone.js is this line. I create a new tone player, and so you need to have this WAV file, and in the end you will send it to the destination if I say kick.start in this case. So there's only 2 lines of code to do that. So let's refactor the code a little bit that we had. This is what we had with these methods as well. So let's shrink it down. Let's get rid of the data wave attributes and only keep the data node attributes. Next up, in JavaScript, I will make sure that the kick, clap, the closed hi-hats, and the open hi-hats are available for me. Because now I can iterate over the paths and say, well, if you and add an event list, and if it's node 40, we play the kick. If it's 43, for instance, we play the open hi-hats. But I want to use this device. Oh, inception there. It's like, I want to use this one. This is a MIDI device. Bye, Mom. For that, we need to use the Web MIDI API. Another thing that's available in the browser, well, almost all browsers, not Safari. Not sure if they're going to support it or not, but still enough. And it makes it easy for you to interact with a MIDI device. Either get data from a MIDI device to you, or send it to a MIDI device. And MIDI is definitely a standard for years already in the music industry. So how are we going to use that? First of all, we need to check whether MIDI access is available. As I said, Safari doesn't support it, so let's check it first. If we have MIDI access, then we can go to the success callback in this case. So what success gives us is very interesting. It's the MIDI access. And MIDI access contains everything we need, like the brand of the device, or the version or the name of the device, but more importantly, the inputs. It's kind of weird in your head because inputs mean inputs for your browser, not the inputs of the MIDI device, so you have to think a little bit backwards there, but we get access to the inputs. And for each input that is available, usually a MIDI device has only one input/output. But in case there are more, we're just going to listen to all of them. And we add the event listener for the MIDI message. If we get a MIDI message, that means I touch a pad or I turn a dial or whatever, I get a MIDI message back. And if we get that, we want to do a handle input. But first of all, let's look how a MIDI message looks. It's simply an array of 3 integers. And I need to drink. And that array consists of the first one, that's the command, essentially. The command can have different numbers depending on the MIDI device, but it can only have 2 values. It's on or off. So if somebody presses the key, it will send, I don't know, for instance, 144. If you release it, it will send, in this case, I think 128. So on and or off. The next one is which node is used. More or less, which button did you press? That is very different between instruments, between MIDI devices, so you always need to check which nodes are available to you. And the last one is velocity. And the velocity means how hard did I press that button, or how far did I turn that dial. That goes from 0 to 127. So 0 is nothing. That's usually also when you release it. And 127 is like you hit that button like an animal. So, we have this. We can already do it in the browser. I will show you after this as well. But I want to do it with a MIDI device. So as I said, we get the MIDI message back, and we can use the handle input method that I created here. So from that input, that's an array of 3 integers. I take the second one, that's the node, so which button did you hit, essentially. And I take the velocity, so how hard did you hit it. I'm saying if the velocity is more than 0, that means that you pressed it. If you release it, it will be 0 in the end. And if it's more than 0, so you pressed it, I will just look at what node you're sending. And now you can see why I have that data node attributes there, because they correspond with the pads on my device. So if I hit, for instance, 40 on my MIDI device, it will click the button that has data node 40 here. You want to see that? Yeah. Woo, woo, woo. Let's see. All right. First of all, let me go full screen here. Let's do it without the MIDI device. So if I just click here, that works, right? Let's make it more interesting. Let's connect the device. All right, it's on. You can see a little yellow square there at audio context. You always have to make sure that there is a human interaction that makes the web audio API respond to you, because if you don't, it doesn't work. In the past, you could just play random stuff on websites without people are able to, for instance, kill it, but that's not the way to go anymore. So you need to give, in that way, permission, and I also need to connect to the MIDI device. And you now can see I have an Akai Professional LPD8 MK2. Wow, fun. More fun is like I can do things like this now. All right, I have to stick to my day job, I think. Anyway, you get the idea, right? But I want to do this. I want to have the TR-909. Because the TR-909, as I said, this drum computer is a sequencer, and nowadays I think everybody uses it to create music, because it gives you a nice rhythm. You don't need to have a drummer that's steady on all time. I couldn't afford the TR-909, by the way. You can buy it on eBay and stuff like now, but it's about 9,000 euros, so 18,000 left. So I don't know if you have money for me. Maybe we can do a little donation afterwards, but I bought another one. I bought this one. This is a MIDI device as well. It has 4 rows. On the TR-909, you have to switch. So it's easier for me now to do this. And what I did, I set up a little page that simulates my MIDI device there. So I have some knobs on the top, pan low, pan high. That means I can move sounds from left to right, for instance. So the lower, the bass, the kick, I can put on the right-hand side, for instance. And then the high notes, the heads, I can put on the left hand, for instance. I also have a dial for pitch, because Tone.js also makes it possible for me to change the pitch of a sound. And I have some samples of people saying words or singing, let's say, so I can manipulate that as well. And I have a dial for BPM. And if you don't know what BPM is, it's beats per minute, and that's the most essential thing back in the day when you were a DJ and have those turntables and you have to sync them up, because otherwise you get double bounces and stuff like that. Nowadays, you just press auto sync. We did it the hard way. But yeah, BPM, you can change that as well. And you can see I have a row here of 16. Well, there are 17 checkboxes. The first one is a round. I styled it as a round one. That means I'm going to mute this whole instrument line. And the other ones are, if it's checked, then it will play the sound on that particular time. So this is one row, for instance. This is the kick. It's just labels with inputs, with checkboxes. The first one has a data mute, so I can interact with that one. And the other one has data node attributes again, as I said. And they correspond with the essential nodes that are sent from the MIDI device. All right. So as you saw before, we get a MIDI message that we pass through a handle input. So we do the same here. We get the node and the velocity again. And if the velocity is higher than 0, we will make sure that that checkbox is checked. Otherwise, it will be unchecked. Next up, we need to have something that keeps on repeating. So that's what I call initialize or init the sequencer. And because I have 16 steps, I'm repeating this over and over at 16 steps, essentially. And I'm using here time, as you can see as well, and time is the internal web API time again. Web audio API time again, not the set timeout or whatever. So it's very accurate. This is a little bit simplified, but just to make sure that you get an idea, the repeat will make sure that it will look at which step is the sequencer is at that point. It will check whether the checkbox is checked, whether it should be muted or not, and which whether the checkbox is checked where the sequencer is at that point. And if it's not muted and if it's checked, then we will start the sound and just go looping all over again. Let me take a little sip. This is not a sad emoji. If you were born in the 70s like me, or maybe in the 80s as well, this is a cassette tape. Anybody remember those? Oh yeah, cool. Yeah, okay. I'm feeling less old now. I'm using this because Tone.js makes it also very easy to record the shitty music you're making. So I create a recorder here, and all I have to do is say, well, if I press record, it's going to record a .start. That's what it's going to do. And if I'm going to stop it, it will make sure that the recording is stopped. I get the recording back, and I can create an object URL out of it that then can feed to the new audio element I'm just creating there. And I have to make sure that it appears on my page, so I append it to a certain ID on my page. That's all. So I want to use this one. You see I have 4 dials on top. They don't really work with the Web MIDI API, unfortunately, because I get either 0 or 127, and I want to be in between, so why not have 2 devices, whatever. I brought it anyway, so I'm going to use the dials and also some of the pads of this one as well. All right, brace yourself. So I'm going to switch, I'm going to make sure it's connected. Let's go to the proper page for that. By the way, in the end, I'm sharing a QR code and a link that you can try it out yourself. You don't really need to have the MIDI devices. You can do it in the browser as well. So I'm going to initialize the Web Audio API and the MIDI device. You can see I now have 2 connected without the brand. And I have little notes because I don't always remember how I want to program this. So if I just hit a button here, you can see it lights up yellow. This one as well. So these are my kicks. And I can set the other ones as well. So let's do programming like this, for instance. Right? I can play it already. So I also have a play button on the MIDI device. So if I touch that, I get a message again, and it makes sure that it knows what to do. Also a stop button. Let's do the other ones as well. Let me see if I can get it right this time. So that line, and let's do the other ones just easy like this. All right, I said I can record it, so let's record some stuff. And let me turn the dials as well. You can see pan low, pan high. Have to make sure that they are in sync. So the BPMs, let's get a nice 124 to get the old vibes from back in the day. So what I can do now is like hit record and mess around a little bit.
Let the music take control.
Cool. Again, I'm not gonna quit my day job, but it's just fun. And also I have a recording now. You can see there I have a player now, so.
Let the music take control.
And what I also can do now is, if I'm correct, I would be able to save it. Oh, hold on. Ah, they changed it. I can't save the audio now. Ah, well, it will be on the video. It might be better as well, maybe. I don't know. Let's switch back a little bit. I don't see any things there, but let's switch back. I want to spice it up a little bit because that's all fun, but I like connecting stuff to my laptop. Why not have a Bluetooth low energy device using that? So Web Bluetooth API is also supported in major browsers. Well, not all, but most of them still. And the fun part is you can interact with it. You can connect with it and get data from it or send data to it. And the way it works is we first have to request access to the device, and it will show a pop-up later on as well. I have to make sure that my filter is correct, so I want to listen to a particular device and a particular service, because I had a friend of mine doing this at a conference without any filters, and there were about 250 mobile phones in the audience, so Chrome said, well, thank you, but I'm not gonna list them all for you. So always make sure you have the right one. And what you can do then is you can create something called a server, see it as an array of objects. And from that server, you will get the service that we, for instance, now use as an optional service, the object. Next of that, from an object, you can get properties. And I want a specific property here that you get with getCharacteristic. And if you have that characteristic, you can, for instance, in this case, listen to notifications of that thing. And that thing I'm mentioning is this one. I have a polar heart rate monitor. I was thinking, I like BPMs. But what about HBPMs? Heartbeats per minute. Right? Maybe we can use that. So every time my heart rate changes or the Bluetooth device gives a message back, I can now read out my heart rate and just say to Tone.js library, well, set the BPM value to my heart rate now. So let's do that. I'm going to load a preset of some stuff. Fateless. I don't know if anybody still remembered those. Good. God is a DJ. I fully agree. So that sounds more or less like this. At 130 BPM. Okay, that's cool. So, I have to turn it on, of course, otherwise it can't see it. It's scanning for the device. Yes, there it is, the polar sense. So I can now pair with it. And you can see I have 0 BPM. Yeah, that makes sense. It's not on my arm yet. So let's see what happens if I put it on. Ooh, I'm very, very relaxed. Last time I did it, I had 80, and now it's almost 60, but let's see how that sounds. Yeah, that doesn't give you God as a DJ vibes, right? That doesn't really help either. Stay in your seats. Excuse me. Thank you. It's not actually what I wanted, but I'm not going to do that because I think I hurt myself in the end. Yeah, you can see it's still coming up. Now my body thinks, what was he doing, in God's sake? I can only say thank you and look at this beautiful 17-year-old boy behind the turntables. And if you want to know more, if you want to have my slides, just go to this website or scan the QR. I'm out. Thank you very much.